Okay, so I want to make a very complicated concept simplified. I want to talk about PCR, the polymerase chain reaction. And PCR is like training your dog. We'll start there. We're going to call DNA the trick. So the trick is like sit, down, roll over, stop, those basics. The trick. Now, primers are the command. So it's the command. It's the sit, no, stop, down, paw, all that stuff. And the treats is basically Taq Polymerase. So every time the dog does the command, we're giving them a treat, right? Keep doing the command, getting a treat, right? So basically, the way PCR works is the DNA is what we're looking for. If it's present, then there's a response. The response is repeating repeating the present DNA. So basically, repeating the present DNA is what we're looking for. Because if it's present, then we know the target is there. If the trick isn't repeated, if the trick isn't done, that means the target is not there, which means the dog hasn't been trained. So if the dog is being trained, that means it's performing the trick, which means the target is there. If the dog is not trained, it is not performing the trick, which means the target is not there. So I'm going to repeat this one more time. DNA is the trick. Primers are the command. The Taq Polymerase is the treat. You cannot get the treat without doing the trick. So basically, you won't get the target DNA if the primers aren't activated, which means the trick is not done. You will get the target DNA if the trick is done and the treat is provided. So essentially, the polymerase chain reaction is looking for target DNA. When it looks for target DNA, when it finds it, it amplifies it. It's like, hey, it's here, hey, it's here, hey, it's here. And then based off how many hey, it's here, we'll know how strong an infection is. So say that the target DNA, so we got like 33 cycles. Say that the target DNA comes up in cycle 12. That means it's hella DNA targets, which means it's a very strong infection. Let's say the target showed up at 30. It's there, but it's a very light infection. It's not like heavy. It's not that much viral DNA, bacterial DNA, which means the infection is probably subsided, or it's just not that much of the pathogen inside this person's body. So the shorter the cycles, the stronger the infection. The higher the cycle, the less of infection or no infection. So when you think about PCR, just think about it being a trick. If the DNA or the command is performed, then you'll get that treat, and that treat is replication. And that treat lets you know that the target has been found. The trick has been done. If you don't get any repeats, if you don't get that DNA found, then the target is not found and the command was not listened to and no treat is given. It's all about replication. And that replication is indicative of whether there's DNA present or DNA not present. But with this analogy, PCR is like training your dog. Did the dog do the trick, or did the dog not do the trick? Is the target replicated, or is the target not replicated? Presence, absence, same thing. All right, well, that was Rough and Pink. I hope I did my best to describe what PCR is and how it can relate to something that's like a real life event. So I hope y'all enjoy.